Welcome, everyone. Let's get started on our journey to master Snowflake Cortex Analyst. Welcome, everyone, and thank you for joining this deep dive into one of the most exciting advancements in data accessibility. Today, we are focusing on Snowflake Cortex Analyst. Imagine a world where your business users, product managers, and executives could simply ask a question in plain English and instantly get accurate answers from your complex structured data without needing to know a single line of SQL. That is exactly what Cortex Analyst delivers. It is a fully managed, LLM-powered conversational interface designed specifically for querying structured data securely inside Snowflake. We are talking about fundamentally democratizing data access. Instead of data engineering teams being constantly bottlenecked with routine ad hoc reporting requests, business users are empowered to self-serve. And because it is available as a robust REST API, you can integrate this powerful capability directly into your existing applications, whether that is a custom Streamlit app, a Slack integration, or a Microsoft Teams chatbot. By leveraging state-of-the-art large language models securely hosted within Snowflake's perimeter, your data never leaves your governance boundary. You get the magic of generative AI with the ironclad security of Snowflake. Let's take a look at this high-level architectural flow to really understand how the pieces fit together. On the far left, we have our business user. They interact with a client application, perhaps a sleek Streamlit app or a Teams chatbot, by typing a question in natural language. This request securely hits the Cortex Analyst REST API. Once inside, Cortex Analyst goes to work. It leverages Snowflake-hosted large language models to interpret the intent of the question. Crucially, it consults the semantic model to gain the necessary business context, and then translates that plaintext question into a highly accurate, optimized SQL query. This generated SQL is then executed directly against your scalable Snowflake compute warehouse. Finally, the structured results are returned back through the API to the user's application. It is a completely seamless, secure loop that is entirely contained within your governed Snowflake environment, ensuring zero data leakage while delivering lightning-fast insights. You might be wondering, why not just plug a standard, generic LLM directly into my database and call it a day? Well, building a production-grade conversational analytics solution is incredibly hard. Generic AI solutions usually struggle with text-to-SQL because a raw database schema completely lacks crucial business context. A generic LLM doesn't know how your specific company defines net revenue, how to handle complex nested joins, or what an obscure column abbreviation actually means. Cortex Analyst solves this massive hurdle by bridging the gap using semantic models. But another massive why is the reduction of operational overhead. Building your own generative AI pipeline requires moving data, managing expensive GPU capacity, and constantly tweaking complex prompt engineering architectures. Cortex Analyst is fully managed. Your data, metadata, and prompts stay strictly within Snowflake's governance boundary. Most importantly, it perfectly respects Snowflake's role-based access control. If a user isn't authorized to see a specific row of data in Snowflake, the AI will not expose it. It is secure by design. This diagram perfectly highlights the stark contrast between a generic LLM approach and the Cortex Analyst approach. Look at the top path. A generic LLM tries to map a user's plain English question directly to a raw database schema. Because it lacks context, this almost always leads to hallucinated column names, incorrect metric calculations, and ultimately, a failed or dangerously wrong query. Now, let's look at the bottom path. Cortex Analyst introduces a semantic layer in between the user and the raw data. When the user asks a question, Cortex Analyst uses this semantic layer to accurately map their business terms to the actual physical tables, applying the correct mathematical aggregations and join paths. The result is a precise, governed SQL query that executes flawlessly. This is how we transition from unpredictable AI experimentation to true enterprise-grade reliability. To make Cortex Analyst incredibly accurate, we must give it a brain that deeply understands the unique nuances of your business. That brain is the semantic model. You can think of the semantic model as a universal translator between the language your executives speak and the technical language of your database. Inside a semantic model, we define several core components. First, we have logical tables. These represent your core business entities, like a customer or an order. Within these logical tables, we define dimensions, which are your categorical context, things you group by, like region or product category. Next, we define facts, which are the raw, unaggregated numerical data points, like a single sale amount. Finally, and most importantly, we build metrics on top of those facts to capture your exact business KPIs. For instance, you can explicitly tell the model that net revenue equals the sum of sales minus discounts. By explicitly mapping these out, we completely eliminate the guesswork for the LLM, resulting in mathematically perfect answers. Let's walk through the architectural hierarchy of a semantic model shown on screen. At the very top level, we have the semantic model itself, which serves as the overarching container. It branches down into one or more logical tables. These logical tables are business-friendly abstractions of your physical Snowflake tables or views. Within each logical table, you define the core components, dimensions for slicing and dicing the data, facts for your raw measurable quantities, and metrics for your highly specific, aggregated KPIs. You will also see relationships defined over on the right. This is a critical component that explicitly instructs the LLM on exactly how to join different logical tables together, specifying the exact keys to use. This structured, hierarchical approach provides the LLM with a highly constrained, highly accurate map of your business reality, ensuring it never makes a wrong turn when writing SQL. While semantic models originally started out as lightweight YAML files stored on a Snowflake stage, Snowflake now heavily recommends an upgraded approach, using semantic views. What is a semantic view? It is an actual schema-level object inside your Snowflake database that stores these exact business concepts natively. Why is this a massive game changer for data engineers? Because it offers profound native Snowflake integration. Instead of managing file permissions on a stage, you get full, native role-based access control, privilege management, and governance features right out of the box using standard SQL grant statements. You can easily share semantic views across your organization or even publish them on the Snowflake marketplace. Furthermore, semantic views support advanced features like derived metrics, which seamlessly combine data from multiple disparate tables. They also introduce access modifiers. For example, you can mark a raw fact column as private, meaning it is hidden from the LLM and the end user, but still available under the hood for calculating complex public metrics. It is an incredibly powerful evolution. In this diagram, we see the modernized architecture utilizing native semantic views. Notice how the semantic view acts as a robust, governed abstraction layer right in the middle of the flow. The business user queries Cortex Analyst, which then directly consults the semantic view object inside the database. This semantic view encapsulates all the complex join logic, metric definitions, and business synonyms. Cortex Analyst reads this rich metadata, formulates the correct SQL, and executes it against the underlying physical tables. But here is the best part, shown by the dotted line. Because the semantic view is a native, first-class Snowflake object, all interactions inherently enforce Snowflake's built-in RBC and dynamic data masking policies. It is a significantly cleaner, more manageable, and highly secure approach compared to juggling standalone YAML files across different environments. Data analysis is rarely a one-and-done question. It is an iterative conversation. A business user asks for revenue, sees a massive spike in a specific quarter, and immediately asks, why, or what about just the North American market? Cortex Analyst uniquely supports multi-turn conversations to enable this exact, natural workflow. When your client application makes a request to the Cortex Analyst REST API, it doesn't just send the new question. It passes in the entire conversation history and array of previous user questions and the assistant's previous text and SQL responses. Cortex Analyst uses an incredibly smart internal LLM summarization agent to understand this context. It takes the vague follow-up question, rewrites it into a self-contained, fully resolved query using the history, and then generates the brand new SQL. This creates a deeply interactive, dynamic data exploration experience without ever forcing the user to awkwardly repeat their previous filtering criteria. Let's trace exactly how a multi-turn conversation flows on this sequence diagram. The sequence begins at the top with user question 1, asking for 2023 revenue. This leads to an initial SQL generation and answer 1 returning the total revenue. Then, the user asks question 2, which is just a fragment, what about Asia? Instead of processing this fragment blindly, the client application sends question 2 along with the entire conversation history back to the Cortex Analyst API. Internally, a specialized LLM summarization agent analyzes the history and smartly rewrites the fragmented question into a fully resolved, self-contained question. What is the revenue in 2023 in Asia? This rewritten question is then passed into the core SQL generation engine, yielding a highly accurate answer too. This brilliant architecture preserves context flawlessly, making the AI feel like a true data partner. Even with an absolutely perfect semantic model, there are always highly complex, convoluted, or incredibly specific edge case queries that a generative model might struggle with. This is exactly where the Verified Query Repository, or VQR, comes in to save the day. VQR is a curated collection of verified, human-approved business questions and their exact, correct SQL queries embedded right into your semantic model. When a user asks a question, Cortex Analyst first checks if it is semantically similar to a verified query in the repository. If it is a match, it uses that exact SQL logic as an unbreakable template, dynamically adjusting filters if needed. This dramatically boosts accuracy and executive trust. Furthermore, you can use VQR to define onboarding questions. These act as clickable starter prompts in your chat interface, guiding brand new users on exactly what types of questions they can ask to get immediate value from the system. This decision tree beautifully illustrates the verified query repository in action. A new user question arrives at the system. First, Cortex Analyst performs a semantic similarity search against the VQR. We hit a critical decision node. Was a highly similar verified question found? If yes, the system follows the top path, retrieving the verified SQL template from the repository, making any minor dynamic adjustments for dates or filters, and executing it. This guarantees near 100% accuracy for your most vital reports. If no, we follow the bottom path, where Cortex Analyst relies on the robust definitions within the semantic model to generate the SQL entirely from scratch. This dual-path approach ensures that your most critical and common business queries are always answered perfectly, while retaining total flexibility for novel, ad hoc questions. Let's dive deep into two highly advanced capabilities that ensure Cortex Analyst never hits a frustrating dead end: routing mode and literal search. First, routing mode. Cortex Analyst inherently prioritizes generating semantic SQL, relying heavily on your governed semantic views for metrics. But what if a user asks for a raw column that you haven't explicitly modeled yet? Instead of failing, routing mode automatically falls back to standard SQL on the base physical tables, ensuring the user still gets an answer while you update the model. Second, we have literal search. Often, generating correct SQL requires filtering on exact literal values that a user might misspell. For millions of product names or high cardinality dimensions, we integrate Cortex Analyst with Cortex Search. Cortex Search performs a lightning-fast fuzzy semantic search to find the exact database literal before writing the SQL, completely eliminating empty result sets caused by typos. This sequence diagram visualizes the incredible power of the literal search integration. Let's say a user asks for sales of iced tea but they spell it incorrectly with just the letter T. The system extracts this entity. Because the product dimension is highly cardinal, it queries a dedicated Cortex Search service configured specifically for that column. Cortex Search performs fuzzy semantic matching and returns the exact, correct literal value as it exists in the database, iced tea. This perfectly formatted literal is then fed back into the SQL generation engine, which constructs a flawless query using an exact where clause match. Without this integration, the SQL would likely use a wildcard search that completely misses the data or returns incorrect results. It is a brilliant synergy of Snowflake's AI features working together. Let's bring all of these incredible concepts together with a real-time enterprise use case. Imagine a global VP of sales who needs to investigate a sudden drop in regional revenue. Traditionally, she would submit a BI ticket to the data engineering team and wait days for a custom dashboard. With Cortex Analyst natively integrated into her Microsoft Teams chat, she simply types, "What is the month-over-month revenue growth for Q3 in Asia?" Instantly, she gets a highly accurate chart. She then follows up, "What about North America?" Cortex Analyst remembers the context, rewrites the query, and instantly provides the North American data. She then asks about a specific, newly launched product, utilizing Cortex Search to resolve a slight typo in the product name perfectly. She gets immediate, governed, mathematically accurate insights, accelerating her decision-making process from days down to literal seconds. This is the future of enterprise data. Thank you so much for joining this deep dive. Please like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Here is our final, end-to-end enterprise architecture summarizing everything we've learned. The VP of Sales interacts via Microsoft Teams or Slack, which acts as the simple presentation layer. This client sends the natural language request to the Cortex Analyst REST API. Behind the scenes, the full agentic AI workflow orchestrates the request. It checks the verified query repository for exact historical matches. It invokes Cortex Search for precise literal resolution on messy user input, and it relies heavily on the native semantic view for governed, rock-solid business logic. The accurately generated SQL then runs on a highly secure Snowflake virtual warehouse, and the insights flow right back to the VP in seconds. It is a masterpiece of modern data engineering. Thank you for watching, and be sure to check out quicktechie.com.